Hey everybody. So first thing I'm going to be doing is going over machine learning just from a high level, and then what we'll be doing is we'll be taking data about people and then determining. We'll do a classification to determine if they have diabetes and what kind of type that is. So this will be pretty much hands-on. It'll be very hands-on. I'm going to go over just a tutorial of machine learning in general, and then we'll dive into it, and I'll kick you guys over the Juniper workbook. If you guys haven't downloaded the materials prior, it's in the
it's on the meetup page.
Yeah, it's on the meetup page, and I also have a little bit more as well. But that should get you guys hands-on, and then it's just a enter and everything, and we'll go through that together. So
sweet.
Yep.
Okay. Anything else before we tell people to scatter? Thank.
We're going to thank Chris. Thank you so much. Even though for those that are not taking the tutorial, it's really amazing to always have different people spending so much time to create tutorials for our community. So thank you so much for that. And we have this, yeah. Yeah, right. And then also we have the space till 9 o'clock. And it would be great if we are leaving early, please clean up after you so that we can be invited back to the space. That would be really awesome. Thank you so much.
Cool. So now's the time to scatter. If you're going to take the tutorial, hang out here. Chris will get started in a few minutes. If you're going to hang out and hack, make your way to the side or to the back or to the conference rooms. I'm in one of the back conference rooms working on the PyBay website, so come find me if you need to, but I will make an effort to walk around and, throw my hand up, stop me, ask me questions. Have fun tonight. Thank you for coming.
All right. Okay. All righty. How's everyone doing tonight? Everyone doing okay? Can you get a little woo? Woo! All right. Cool. All right. So this is the tutorial for machine learning. Get your first hands-on in this. If you've already played with machine learning, then this might be not as fun, but it will go through the process of just the basic understandings of what machine learning is and how to understand it a little bit more. I'll start with a little bit about myself. So I did most of my schooling in Sacramento at CRC, Sac City, came to San Francisco, did City College of San Francisco. From there, my background is in information security and cybersecurity. So, more so, I've been moving into malware analysis, and I've been picking up cryptocurrencies just because it's fun as well. I'm one of the co-founders of the Hacking Club at SF State, and then we have the most recent president over there chilling. Woo! So yeah, give him a little round. So. Co-founder of a company called Cryptmos LLC. We supply machine learning intelligence to crypto hedge funds, and then they pay us based on the gains that they make. In the last year, 2017, there have been many crypto hedge funds that have started up, so we're targeting them specifically. I spent 5 years in InfoSec, starting as a security analyst, then moved over towards doing research. And now, so I'm doing malware research with a startup currently. So, and then hobbies include cryptography, cryptocurrencies. I like CTFs, economics, malware analysis, machine learning, reverse engineering. So that's a little bit about me. That's my dog, Mr. Robot, and Elliot. Yeah. Okay, so why machine learning? It's the ability to learn about your data from a scientific perspective. You might have data and not know exactly what you're looking for, but there might be something very specific there that it can tell you. Or maybe there's something that you really want to know or divide up either through classification or regression to tell you exactly what it is you want to know. So I think if anyone's dabbled in ML, like the most common one is they use for is like housing market data, So how much is your house worth? They base this on features such as your room size, the rooms, the size of the house, and the zip code, and a few other things. How many of you are familiar with Zillow? Show of hands. A lot of people. Okay. I think this last year, they had a competition that they were trying to increase their pricing algorithm by like minimum 5% or something, and they were going to award the winner like $1 million. So there were many groups that competed and stuff like that. So this is a very huge application there. Geographic marketing data. So if you have enough data about where certain shops are located, you can start to better understand where you should set up a business. Mortality and insurance, a little bit more of a darker side of the data science field, but it's also something that can be used and is fun to look at sometimes, depending. And then market predictions as well, so like stocks and other types of things, cryptocurrencies, whatever. And then I just looked up the different careers. I went on angel.co, which if you're looking for a job and you're looking for startup, it's a great site. It allows for people that are in the startup world to search for people that are looking for something of that smaller type of environment. Most positions start at 6K, I mean 6 figures easily. NLPs, natural language processing, senior data scientists get paid a little bit more, but almost anything that you do, you're going to get paid pretty well. So it's a good field to look into if you want a little bit bump in pay, potentially. As for the types of machine learning, so this is really fun. There's supervised learning, so you have different features that are already given. So you know that one of the columns is the size, height of your dog or whatever, or the width of your dog, or whatever it may be. So you know what those are already. Now, with that, you can also do classification. So what kind of breed of dog is this, right? Is it a Shih Tzu? Is it a Corgi? Based on certain things. Also for people, male, female, other. And as far as regression, so that's classification. So you want to know like what of these types are there. Then you have regression. And regression gives you a specific value. So it's like, given these parameters, what would the price of my house be? And it gives you a type of prediction. Then you have unsupervised learning, and unsupervised learning, you don't know what the features are, so it's not given. So you just get a bunch of data and then have to determine what kind of breeds they are based, like if it was a dog, determine what kind of breeds they are based on the data. So you'll see these clusters and then kind of like say, okay, well, this dog fits in this cluster. Maybe this is for a Chihuahua. This one's a Great Dane, it's a little bit way over here, And reinforced learning. So I think one of the coolest videos I've seen in reinforced learning was this Mar.io, is what this person was calling it. He trained Mario to beat the game, gave Mario all the buttons and options that he could do, and then just had him keep learning. And what he did was he said, Mario, if you get to the end of the game, you've reached 100%. And the further you progress down, the better your score is. So in the event where you're comparing this score towards one where Mario just runs to the left or the other side, it will say, okay, well, this one was the better result. And then after many steps and iterations and learning, Mario figures out, oh, I need to get over there. So you weight the different learning experiences and rewards that Mario can have. And obviously, if you die, you failed, Mario. All right, so some of the flaws that happen in machine learning models, you can either overfit your data or underfitting. The black line would be a great representation of what the data is. I mean, a perfect line, or curve, as it were. Overfitting would be that green line. So you see how it's grabbing every specific blue line, or blue dot. The problem with this is once you start introducing new data, it's not going to be as effective as that black line would be. So the issue is like once you give the data to your model, it's going to learn from that. And what you don't want to do is say, okay, if given these parameters exactly the same, we will get the exact same results. The problem is if you get data that's a little bit outside of that. So you want to get the best general case. This also works for malware analysis as well. So the first one you have underfitting. The second one is like pretty good because it's the curve, and then the overfitting is when it starts touching everything, right? Okay, so let's do a little bit. Let's do an exercise. So I'm going to show you one, and then I want you guys just to yell out which one you think it is. Everybody ready? Yeah. Everybody ready? Yeah. All right, cool. Okay, 1, 2, 3. Okay, yes. Actually, I didn't even point to it. You're right. You would have been right if you said anything. So the blue line is overfitting. The red line is exactly what you want it to be, but the blue line, overfitting completely. The next one. What about this one? Got it. See, these are easy. Next one. And then that one. Perfect. So, the process of machine learning, and this does not change whether you're doing unsupervised learning or any type of learning. So this is it. This is everything. And what's great about Python, and what I loved about picking up TensorFlow, was I came from the Coursera Stanford class by Andrew No, who used Octave, which is just another language, but it was interesting. I really wanted to pick up something that was Python based, or especially Google, because I know that Intel just released an AI cloud that allows you to push TensorFlow jobs to their servers, and those clusters were made specifically for that. They released a CPU last year just for that reason. It's probably still like Meltdown and Spectre vulnerable, but that's beside the fact. That said, that's when I started realizing I need to get more into hands-on with TensorFlow. So what's great about TensorFlow, it's easy to set up these neural networks. So the process goes from you get your data, however you get your data, you sanitize it so it looks best in the way you want to present it, and then from there, you create your model based on that data. After that, you train the data, and you say, okay, I'm going to feed in the data. Now, what you do at this point between the training and the testing, or the evaluation period, is you take all of your total data. Let's say you have 1,000 entries, and you divide it up. You say, in class, we've been doing like 70% to 30%. So you take 70% of it, or whatever you want. So you're the data scientist. You get to decide. That's the fun part. 70% to be the training data. So your model will start working on that 70%, those 700 entries. After that, you say, okay, model, you're trained. Now here, take that last 30% and tell me how well you guess the answer. And that's the evaluation. So you remove the answer and says, here's this, what do you think? And then it says it, and then you either say, yes, that's right, or no, that's incorrect. So by actually increasing your training size, or training set, you can actually increase the your model itself. So after that, you can you do the testing, and then you can change different parameters as well, and then you go into deploying your model into the real world, at which time you'll receive new data, and that new data will hopefully be in line, and you'll get the results that you want. Does anyone have any questions so far? I don't know if I feel like I'm... Yes, please. Yes. So the train, so the question was, I think you'd like me to explain why the test jumps over the train model. Is that correct? Yes. Yes, I understand. So the reason why it jumps over to the train evaluation is because the model has already been trained. So the model itself is what it is, but once it's tested, then it becomes an evaluated model, which already has the training model properties, if that makes sense. Okay. So yes, I understand the confusion. So after you receive the data in the acquisition, you clean the data. At that point, you take 70% of it, and that's the train data, and then 30% that's not a part of the train data as the test data. Yeah, so I think that was I had that issue when I was trying to understand this. Yeah, so the test data has actually not been into the train model at all. So that's I think what might have been confusing. Yes. Yes. So in the event where you might have data that's very sporadic, like what were we doing? We're doing Bitcoin value data. So instead of, and we're actually doing value data just as a general. So Bitcoin is at think it's at 11,000 right now, and you'll have another coin that's like at 5 cents or something like that. So those, I can't just take all of those points and say, okay, let's just see, the highest will be 11,000, the lowest will be a penny, because relative to the coin, it has to be in the same range. So what you would want to do is use like a sigmoid function, which would allow it to be of range like 0 to 1, and have it like normalize that area per coin. So, yeah. Yes, please. Yes. So his question was, do you randomly select the test set? It really depends on what you're applying the science to. For most of the cases, we've just been doing random iterations because it doesn't rely on time. In the event of time series analysis, you would want to have it linear or chronological. Yeah. So, all right. We'll go to the next one. Okay, so process of getting the data. How many are you familiar with Kaggle.com? How many data scientists do we have here? Can I see like a few hands? Okay, all right, sweet. I'm very new to this area, so this is all brand new to me. Yeah, so Kaggle's a very cool, very interesting site. It gives you the data set. There's competitions for people to compete in like a data science field, so you're easily able to get your hands and feet wet playing with like different data and stuff like that. I'm new to it. I'm just starting, but I'm really excited to have like a beer and just keep playing and seeing how far I can go and like how precise I can get the data. I think one of the entry ones is Titanic. You get to determine based on the many different variables, the sex, the class of where your room was, and a few other things if you would survive or not, or the likelihood of you surviving. So that's fun. Other places you can get your data, data brokers, as well as companies and businesses. Obviously, if you're working somewhere and they're like, we want to find these things out, you can easily do that. So this is the part of the sanitizing the data that I explained earlier about different prices. When we were doing Bitcoins, cryptocurrencies, Bitcoin is one coin value that differs from like Ripple, Monero, and other types of coins. So we want to normalize that before we start actually applying it. There's different types of, these are called perceptrons, sigmoid functions, hyperbolic tangents from -1 to 1. And a lot of this depends on the data that you're applying it to. And this is where you divide the data that I expressed earlier. So you have X train. The capital X is supposed to represent a matrix. Lowercase letters are supposed to represent a vector. That Y label should be a lowercase y, but it's not. The X train is the matrix that you would do for the training set. Eval is the one you would do for the evaluation. All right, so now you train your model. So one thing that you would do is apply a cost function. I'm not going too deep into the different types of cost functions. I'm not going to be going too deep into different types of descent or gradient descents, as well as back propagation. It's more just a high level of how this works. So cost function measures how far off you are from the real value, and then tries to bring you closer over and over to that one point. So, and it does this by gradient descent. It takes very small steps to get you there. In the event where the learning rate is too high, you might never find it. So a lower rate and many steps will get you exactly to that sweet spot that you want for your model. Okay. After you train your model, then it's time to evaluate it. So after you send in the X train set of 70% or 700 entries, then you do the X eval set into the same model, and then you test to see how true the answers are. So you have MAE for mean absolute error, mean square error for MSE, and then root mean square error as well. Yeah. Then you deploy your model. This is the last step. You allow new data to come in, and then you're going to hope that the precision is going to be the same. I believe after time, any model will shift and stuff like that, but depending on how well your model is, depends on how well it'll last. So, but yeah, so that's the general sense of how to build a model. Now we're going to go into the workshop prep. So we'll talk about building models from here, and the example that we'll be using and stuff like that. So I have data for everybody and stuff like that, so we can start playing with. I also made a Juniper notebook. So this part's going to go into the workshop. So if you guys want to learn more about the hands-on part of it, you guys can please stay. If not, then feel free to walk around and run around. Yeah, so now we're trying to determine if person A has diabetes. So given these characteristics, we want to know if they have diabetes, and if so, what kind as well. So this is a classification model that applies at least 3 classes. So yes, no, you don't have diabetes. You have type 1, you have type 2. Those are the 3 that we look at. And these are called features. So these are the columns that we have that describe the individual. So we have the number of pregnancies, glucose concentration, blood pressure, try this, insulin class. So the class and the group determine the group itself. I think determines exactly if they have diabetes or not. Class, I believe, is, I think it's financial class. I'll have to double check. Age, pedigree, and BMI as well. So all of these are considered features in the world of ML. A label is considered the result. So in this case, it would be one of the groups. So a label would be, yes, they have it, no, they don't, or what type they have it as well. So we look at all of these factors, and then we want to create a neural network from these. So the question is, what would be the input layer, what would be the output layer, and the hidden layer, and how many hidden layers are there? In this event, we only have one hidden layer, and that's with all our features, and then from that, it gives us our output. So in layer 1, our input layer, it doesn't go all the way down to the amount of people we'll be testing, but it keeps going down for every person we have. So that's the input layer, every single person, every single entry. The hidden layer are every single one of those features. So each one of these will be one of those sets of features in the hidden layer, and then our output layer will be, do they have diabetes? Yes, they do, they have type 1, or they have type 2. Okay, sweet. All right. So that's what I have just for the presentation portion of this. Now, as far as the workshop goes, either we can do that here, or how many people want to stay and do the workshop? Because it'll give me a better understanding about, okay, cool, holy shit, okay. It'll give me a better understanding if we should move or stay here. So with that, we can stay here. What I'm gonna do is, I'm going to pull up a little sheet so you guys can grab the data, and then we'll go from there. I did a tiny URL, did 2 of them. So we have SF Python -ML. What's the other one? And the SF Python -ML will get you to my Google Drive, which has all the information you're going to need. And this was the other one. And this is the workshop we'll be looking at, or the thing. So let me get you guys that. Okay, cool. And then the second one is tinyurl/Chris-ML-fun. That one will have that links to my GitHub, which has the instructions on how to do it. What am I looking for? Oh, there we go. Cool. Does anyone have any questions? Yes.
CHRIS is the tiny earl.
Yeah, so I misspelled my own name. CHIRS is what I put, so, yeah.
For security reasons.
Yeah, exactly.
Obfuscated.
Did everyone put their full name when they signed in here? Part of it? Okay, Chris also, yeah, okay, now Chris also works, so you can, however you want to do that. Cool. That's so tiny. And this is what'll come up. These are my notes that I took. I took this off. I learned my ML from the Stanford course, but also the Udemy course. It's one that has like the most likes or reviews or whatever. Definitely recommend checking that out. They probably explain it way better than I do, because they've had so much going, so many students with so many questions and stuff. So, but yes. This is what we'll be using. So, how do I want to do this? Does anybody need assistance setting up? Please.
I'm on Mac OS.
Okay.
And when I try to build my content environment, I got a bunch of unresolved packages.
Okay.
Do I need that extra script that you may need for Mac?
Yes. Yes. You're gonna need that. That's the only way I got it to work on mine, is by running Conda.
Conda. Then I run that shell script.
Yes. So I tried. Oh, okay. You said you installed Anaconda and then tried to run the shell script?
No. I tried to run the, Conda create m.
Uh-huh.
And then he gave it the YAML file.
Okay.
And I get a bunch of unresolved packages.
Okay. Okay. I'll. Oh. Does anyone else have any questions? What was that? This one? Oh, this one right here? I think this one was used to, at the very end. Oh, splitting the data, yeah. it divides up your test data. Yeah. Yes. So I can barely hear you. If
I said, the question is, why are all of the people inputs to the model, and then you only have one output because they have diabetes or they don't have diabetes?
Oh, so why is there multiple inputs and then the?
Why are there multiple people that are inputs to the model when we're trying to figure out if a single person has diabetes?
I see. In this case, I believe we're looking to see if everyone who has diabetes, not a single individual. The single individual might happen if we were adding new data into it, but then we wouldn't be learning. But that said, we're taking all of the data, so 1,000 people, and determining of those 1,000 people who has diabetes, not diabetes, kind of diabetes as well. Yeah. Cool. But yeah, okay. So raise your hand. Can I see a few hands who is ready for the next step? We have a few people, kind of a few people. Okay. Does anyone have any questions? I think I might have seen a question. Yes, please. Great question. So there's two of them. One of them will take you to this site, or my GitHub that has, it explains exactly what to do step by step and actually has the answers. And then the second one will take you over to my Google Drive, which will have this package. Ooh, I don't need that. Which will have all the relevant information that you'll need for the workshop. Yeah. Yes, that's a great idea. That's not it. There you go. You can spell my name correctly or not. It's fine. I don't mind either. Cool. Does anybody need help? Don't be shy. If you raise your hand, somebody will help you, or I'll try to help you. Yes. Sure. Yeah. Come on up. This slide you here.
Trying to get virtual environment to happen. For some reason,
Okay.
I just keep getting this, even though I have TensorFlow on my computer already.
Okay. It looks like it's still. Is it still working though?
No, but then I got this, and I'm getting no module named TensorFlow.
Oh yeah. Let me see.
You know, I was trying to do this last night too. I could not figure it out.
Oops. Yep.
Install TensorFlow.
Yeah.
It's over here.
Really?
Here, try.
Mind if I try?
Yeah, do sudo too.
Alright, install.
So you can't.
Okay, so everything's already installed.
Yeah. Isn't that really odd?
Yes, it is. What did I do to get it working last time? Oh, you can even do two. That's cool.
Yeah.
Still not like it?
Yeah, it still
doesn't like it.
Why is that? It has all the other ones because I've used the other ones before. TensorFlow is the only one I have used on my download.
It just didn't work?
Yeah.
I'm not
I don't want to
sure.
take up too much more time with the thing. My buddy's got it next to me. I just kind of wanted to do it.
Yeah, of course. You should just install it like without, was it installed regular? No, 2.7. I don't know.
Okay. All good.
I'm sorry.
It's all right.
So I did the Minicon of Baxter number one package and I found ICU. Do you know why I wouldn't have that?
I'm not too sure. I don't
Okay,
think
all right,
that
I'll
we
just-
used it either, so you might be okay.
Okay.
Yeah. Yeah. Cool. Anybody else have any questions? Python 3. Two might work, but I have not tested it. Okay. How many people are ready for the next part? 1, 2, 3, 4. Okay, all right. Okay. For the people that have it not set up yet, in the event where you want to see what's going on, you guys can probably link up with somebody who does have it working. If you're willing to like share your screen with the people that don't have it working, the people that do have it working, would you mind raising their hands? Cool. So if you don't have it working and want to work with somebody, the people with have their hands raised can help. Great. Okay. Okie dokie. Keep this up. Not this. Okay. Cool. Okay. Oop. Check this out. Okay, so everyone, or most people have this. Is this correct? Can I get a show of hands that have this part pretty much going? One person? Okay. Do you guys want a few more minutes to set up? Yes? Anything? Yeah? Okay. We'll take another 5 minutes. If you guys already have it set up, then just relax. Is anyone having difficulties that I might be able to help out with? Yes. Okay. You're not the only one, so let me look. Would you mind bringing your laptop up, and then maybe if I find a solution, everyone can have a solution. Okay, yeah, that sounds accurate. Okay. Okay. Is it here?
It's on the browser.
Okay.
I'm on the juicer part.
Okay. Okay. Oops. Have you Googled the air?
So I actually didn't realize I needed to download anything until
No worries.
just about 30 minutes before the workshop started.
Got it.
So I was like, crud. So I'm just now getting to this part.
Not a problem. Let's take a look. It's frustrating. It's almost 3 hours. Solve, see below. I'm gonna move. Move these way more. Yours on here more than mine. There you go. Is that okay? Oh, we could also just put it here. Okay. So it's working. Let's double check to see if it's working. Oh, you know what? Let's just work. Okay.
I can just sit and watch and try to replicate stuff later on my own time.
That might be it. It's very good. Did you do the start? Do you know what command you did? Do you know what command you did to bring up the notebook?
I'm not sure. I know that at I do have it up on
Oh.
screen there. So I think it was about here on the screen. Been further along. Yeah, it was a bit further along since after the YML file was ran. Yeah. Yeah, it's the activate
Yeah, deep learning there. So it means that the activation is good.
I think it then went, I think it was the name changed it to Python.
Yeah. Now let's try. Woo!
All right, thank you.
Of course.
So what was the ultimate issue with it?
It's like it was a pip install, and then we installed it, and then we just restarted the computer. I think that's what it was.
All right, thanks.
Yeah, of course. Okay. Yes.
This here is a Windows environment file.
Probably.
And then because, like, this is what I get, right? When my code is missing.
Oh, yeah.
Like, is that Visual Studio Code or something?
That's a very good assumption. Yeah, I would say so.
Maybe you saved it with like your Windows.
Yeah. So yeah, my there was a script that I have in there that if you run on the event page, it says if you have Windows, use this one.
So I saw this script here. You said like, hey, if you have Mac, you might want to use this, right?
Yes.
When I opened this up, I noticed that Minicon.3.
Yeah.
So instead of running this, I just went on this website and downloaded their shell file.
Okay.
Would it be the same thing, or did you make edit any of
I think it's the same. Yeah, I didn't edit any of it. So yeah, it's the same.
it?
So you downloaded? Did you do that one?
I did the shell Minicon.3.
Okay. Okay.
It's
Yeah.
actually right here.
Yeah. Okay.
That's what I ran.
Yeah.
But, oh yeah, when I ran that. Yeah, check about this. Oh, you know what? I messed up this time.
That's good. That's good.
I had to change the permissions.
That's good. Okay, so we had a few people that had some problems, ran into some problems and stuff like that. So one of them for Windows, if you do pip install TensorFlow, it'll get the installation working, and then you'll be able to restart your Jupyter notebook, and then that should be good to go. As far as the installation file, changing permissions will help for that in terms of the Mac requirement. Does anybody ever have any other questions? There was a video tutorial for that one. I think typed in Jupyter Notebook. He did something like this to start it, and then the source one for that. But okay, what I'm gonna do now is for the people that are ready, we'll start. I will record using a QuickTime, and then you guys can follow along. I'll upload the video so you guys can follow along afterwards. Does that sound good? Okay. Okay. Cool. Everything. Whatever. Okay. Okay, so if you're following, we should all have the same ML workshop page. So what I did was I gave you guys all the imports immediately, so it's just easy. We don't have to say what to import, figure that out. So we're just gonna, if this is your first time using Jupyter Notebook, which I love Jupyter Notebook now, if you just hold Shift Enter, boom, it runs everything right there. So, and then you can continue on. So the next part, the first thing we want to do is import the CSV into a data frame. So if you're familiar with pandas, this should be good and easy. I was not. I didn't know anything about linear algebra, and I barely knew. Yeah, I didn't know anything about linear algebra. I didn't know anything about pandas, NumPy, and matplotlib either. This was all just the prereqs to get into the ML portion of it. So what you can do is you name the variable as you do in Python, make it equal pd for pandas dot read underscore csv, and then the name of the file. So we want to do the PIMA data, and if your Juniper notebook is pointed to the location where the CSV file is, you can just hit tab and it'll autocomplete. In the event that it's not, Jupyter Notebook also runs, at least in Mac, it runs like a new Linux command, so you can do like ls, cd, and other types of things, so you can find out where you're at and such. So, yeah. So now we want to. So now that we imported it, let's look for the first 10 entries. So what you can do is diabetes dot head function, and then it'll give you a few of them. You can also change this to 10 on the inside, that parameter, and then it'll increase it, give you a few more. Okay. Can I see the hands of who's like following so far? Okay. Okay, cool. We have a few. Thank God. I don't want to be the only one. And as for everyone else, like it'll be recorded, so you guys can have it. And if you have any questions, please contact me. Okay. So now we want to show the columns. So as we go down, we can type in diabetes.columns. Is that? No, I don't like that. What did I do different? Yeah, I think you're right. Yep, can't spell. Diabetes.columns, and then it shows us the columns that we have. So that's great. Now we can know the features that we want to use and which ones we have to remove. So again, we want to remove the answers. So we don't, because we have 3 classes, we have a group. So A, B, C, maybe there's a D, I don't recall. I guess we could look up here to see if there was, right? So we have at least class A, B, C, and D. Yeah, so we have multiple outputs. So maybe it's type 1, type 2, and type 3 diabetes or something. In the event where it was just binary, like you're alive or you're dead, unless you're mostly dead, you would just have a 1 or a 0 that could be represented. We're going to go over how to categorize those outputs. But for right now, what we want to do is we want to get the columns that we want to normalize. So we'll type in COLS for columns, 2 norm equals, and then we'll start supplying our column names. So number pregnant. Then glucose. Insulin. BMI. And pedigree. Cool. So I think I did that correctly. I'm just going to steal it over here just in case I messed up somewhere. Cool. And so this next part, we're going to apply a lambda function that will allow us to normalize the data in the specific columns that we want to normalize. So right above, we just created a list of all of the categories that we want to normalize that data for. So now it's going to, by column, normalize it. So again, what that's doing is it's taking, it's applying a sigmoid function so that the values will either be, in those fields, will either be represented by some number between 0 and 1. And what it does is it takes the highest value and then takes the lowest value and kind of just tries to shrink it into a form from 0 to 1. So usually you'll have a real long trailing decimal number. Does anyone have any questions? Okay. And again, this is good for like if you have data that's really, really all over the place in terms of pricing values or other types of things. Lambda x dash, and I'm sure there's a 2-line Python way of doing this. This is just another way to do it. So please, if you guys know more effective ways, please do. And I have enough of these. So we did diabetes columns to normalize, and then we did diabetes column normalize dot apply. So we're applying that function, the lambda one that we're creating right here, which is x, so the input, minus the x minimum, so whichever is the minimum, divided by the value of x max minus x min. And I'll leave that. And then we just check diabetes again, the head. And as you can see, the number of pregnant has changed from numbers like 6, 1, and 8 to 0.352941. So we know that the data has changed. Okay. Don't need to check all that stuff. Okay. Sweet. How are we looking? Are we on the roll? Still moving? Head nods? Yeah. Okay. All right. The next part is where we'll be creating the neurons, specifically the hidden layer. So this one we want to point to our columns and say this column is important and we care about it. So from here, let's start with the first one. Num underscore PRG for number of pregnants equals TF for TensorFlow feature dot column dot numeric. It's a numeric column, so we gotta spell it right. And then number pregnant, which I'm not gonna butcher. Boom. So spell feature wrong. Oh, underscore column. So cool. So we have that first one done. Now we just do it with all of these other ones. So you can name them whatever you want. Just make sure that you remember the name of them because later we're going to be putting them into a list. That's what we're going to be doing. And if you don't feel like copying all this down, it's in my GitHub, so you guys can copy paste it if you want. But I think the fun comes from actually like typing it out. I'm not going to type all these out. I'm probably do this last one and just copy and paste it. Okay. Who needs a little bit more time? Oh, please. Yes, great question. So the question was, what are these neurons for? These are the activation neurons. So in my picture, I have a picture. It's right here. It's somewhere here. Here it is. This thing. Yes, so that is these hidden layers. So every single one of these is a feature. And what happens when you say like, oh, is pregnant or has been pregnant, this will have a value at it. And what it does is it takes all of these and then determines where it should go as the output. And when it makes a guess, it's like, oh, this person has diabetes. Their BMI was this, and it says no, that's incorrect. Then it goes back and says like, shit. Well, okay, well then what if the BMI was this? Is that correct? And it's like yes. It's like okay, then the BMI needs to be weighted a certain way. So it does this so you don't have to go back personally and do the maths. Machine learning is just really just fancy math. That's all it really is. It takes away a lot of the magic, but it's still a great tool nonetheless. Did that answer your question?
Yeah, so this kind of like builds the correlation.
Yes, exactly. It builds one of the key components of the correlation and allows it to understand how important that item is to the outside, to the final results. How much weight does that have? Well, essentially what it's doing is it's trying to determine how much weight is to be added to that specific neuron, to that specific area. Any other questions? Do some people need more time? You ready to go to the next part? Anything? All right. Well, we'll power through and keep going then. Okay. So now to create the Y label. Now the Y label is the answer of the person. So given this information, the Y label are those results. So what you want to do is you want to remove the answers, the results, from the data that you send in, and then provide the model, say, okay, here's the data, and then here are the results. So that way when it takes in the information, it'll look to see, okay, this is this, I think it's this, and then it'll look at that corresponding result to say like if it's true or not. And if it's not true, go back, change it. If it is true, cool, score this higher in terms of those features. And saying like the weight is correct, at least for this specific example. Okay. So tf.feature underscore column dot categorical underscore column with, yeah. And you can use tab. For this one, we're going to use a vocab list. So in this, there's two types of things. You have a vocabulary list, and then you also have a hash bucket. Vocabulary list provides you the option of inputting what the potential results are. So because we know that the group can only be of 4 types, A, B, and C, and D, we can do that. In the event where you have to categorize them by, let's say, country, instead of going and creating a list of every single country and their abbreviation, you can just do a hash bucket, and it will just take the hash of that and then save it and then look to see if that hash is there, if that hash has been saved. And if not, then it will create a new hash. So we're going to do a vocab list bucket for that. So the first part you select is the column name, and then the next part are all of the potential outputs. Okay. And then here we can look to see the different age ranges just of our data set. So we can see that the majority of people are in their 20s to 30s. This is what the survey grabbed from. Okay. Any questions so far? No? Okay. Now what we're going to do is we're going to create a bucket for the age groups. So this basically just puts them in a specific grouping, so it makes it easier for the analysis. So you can say, oh, between 20 to 30, or 30 to 40, 40 to 50, and so on. So tf.feature underscore column dot bucketed items column. Then we want to say age, because remember we have it saved up here. That age is our feature column for the string AGE, capital A. And set our boundaries. Yep. Cool. So now what we're going to do is we're going to create that list that we had up here for all of those our TensorFlow feature columns. So we'll do that right here. Call it feat columns or calls. I'm really just going to copy paste this. Boop. Cool. Sweet. How many people are still with us? A few people? Okay. Do we need a little bit more time? Raise your hand if you need more time. Okay. Just to explain the next step that we'll be doing, we're going to be removing the Y label from the data set, and then we will be having our X data. So that is all our data, just without the results. So we have the X training data as well as the X evaluation or test data. No, please. Yes. I think it, so what I believe it does is that it categorizes them. So in the event where it's between 20 or 30, it'll just classify it and group that in one specific group. So yeah, so it's like, oh, it's in group 20 to 30 or whatever. That's this thing, and then oh, was this result correct? Yes. Okay, so that's a correct weight on that age. Which, yeah, exactly, grouping it up. Yeah, you got it. Okay, we're gonna continue moving. Again, I have this recorded. So the next part we want to do is remove the Y label from our data matrix, which has all of our data. So shift X underscore data, and you can call it whatever you want. I've been getting used to doing it this way. The X representing the matrices, and then the data representing all data, including training, our data that has our training and evaluation data that has not been split yet. So we do that. Diabetes dot drop because we want to remove class, and we will do access 1. I just remember if you do 0, it's bad. I think it points to where it's at, but I'm not sure. And then we'll just look to see that's there, that change has happened, and we don't see the group, we don't see the class there anymore. Whatever. Yeah. That's a great question. I don't have that answer. We could probably put it. We already dropped it. I'm not too sure. Actually, let's take a look. Yeah, let's do 1. So that'll show 1. Let's try 2. Doesn't like that. Try 0. Doesn't like that either. Yeah, so 1 seems like chill. And I think I misspoke, and I apologize for this. I think the class is actually the answer. So if that's the Y label, yeah, you either have diabetes or you don't. I have no idea what that group is then. But we had to use that so we can use it as a feature. So that's why we classified it and wrote that vocabulary list. But no, the class is to represent if you have diabetes or not. 0 being no, 1 being yes. So that's why we dropped that, in case there was any confusion. Any questions? Oh, Jesus Christ. Okay. So now we'll just create our answers. Labels equals diabetes class. Maybe it is the answers. I don't know anymore. Maybe it was type. I don't fucking know. Age. Okay. Okay, so this part is where we actually divide up the data. So we have X data. Now we're going to divide it up to X train and X test. And then we set the parameter for how much of that data do we want to put on our training set, and how much of it we want to put on our testing set. So for this one's actually like, even in the class, they're kind of just like do shift tab to get the answer, to get the output. So you can do train underscore test underscore split, comma, comma, and do a shift tab. And if you hit tab again, you can get this little nifty, like that. This little nifty part right here, and copy pasta that. That's just a neat little trick that they showed us. Equals. So that way you have your output. So your X train, X test, Y train, Y test. Y train being the answers to the training set with respect to X train, and then Y test the same for X test. And then you feed in your data. So you just say X underscore data, comma, labels, your answers. And then test underscore size equals 0.1. And a gentleman asked about the state of if you want it to be random or not. This is where you can set it to be random or not. If you do random underscore state equals 101. If we all do 101, we'll have the same results. If you guys do 102 or whatever else number, our results will differ because we will be receiving different. Our data sets will be different. My test set will be different than your test set, and my training set will also be different than your training set. So you will have different values. We have all the same data set, but as it's broken down, that would be different. Does that make sense? Good. Cool. Okay. Anyone have any questions so far? Yes, please. Oh. Great question. So the question was, is that going to take 101 records? Yes. So that's not, no. What it's going to do is that's the seed for the generating of the randomness. So yes, sir. Yes, I believe so. That's I didn't look that up, but I assume so. I'm hoping their crypto is great, but I'm assuming that. I don't know. Okay. Any questions? Okay. so now we'll create the input function for our training set. Input func equals tf. So we use tf.estimator .inputs.pandas. And depending on how you want to input your data, depends on which one you'll use. You can use NumPy. You can also, and pandas is the other one. So I guess you have those two options. That really messed me up when I was trying to figure out what was wrong once. So we're going to select xtrain for our training set for the x values, and then y equals our y_train for our y values. And batch size, so you can do this in different batch sizes. We generally just do 10, but feel free to change that number. I'm not familiar with how the batch sizes actually work. That's something for me to research as well. Number of epochs is like how much time actually goes by. By increasing this, you increase the amount of learning your model will be receiving and the amount of time it has to learn. I've noticed that increasing this will increase your accuracy, but I think it's there's a teeter off point where it just doesn't matter how long you give it, it's not going to get any better. And then shuffle equals true. And then you can also shuffle your inputs as well. Here, let me. Cool. We're not even doing that as well. Okay, so we're almost at that point where we get to build our model and then start training it. Here. Yes, please. Yes.
So the previous function is you split between x and y, which is your I guess your variables and your outputs, your actual answers.
Yes.
But you also have a split between train and test.
Yes, sir.
And on this input function, you don't mention tests at all.
Yes, this is correct. So, thank you for asking that. So, his question came to the effect that we don't add the evaluation or the test set into this model. So, yes, I have a slide for that somewhere. There you are. So, this guy. Okay, yeah. So, is this a laser? Doesn't have a laser. It does. Look at that. Okay, cool. So, yeah. So when we're training our model over here, we don't add in the test data up here because we want to train the model as if there was no test data. So we're like, this is the only data you have. It's the only data you're ever going to get. So build the model the best you can. Once it does, then we say, okay, let's test to see how well our model is. And because it's all from the same data set over here, we just split it up. So 70% of it's coming into the training model, and then 30% of it's going into the evaluation portion. So that way, at the end of this, once we train it, we're going to say, okay, so now we have to guess and see how good it is. So then we take the training set, pop it in here, and then we get a percentage of how well that training set, or that test set did.
So right now, we're just throw the walls and then later like that. There's no weight to see how it's
Exactly. Yes. Does anyone else have any other questions? Okay. Okay. Cool. All right. So let's build the model then. So model equals tf.estimator .linear. So dot estimator, and then you decide what type of model you're building. So in this case, we're building the linear classifier. You can also use a regression. You can use linear regression, which will give you a value instead of classifying different things. So in this case, we want to know what type of, if they have diabetes and what kind of diabetes they have. Linear regression would be tell me the value of the house given these parameters and like how close you were and were you correct and stuff like that. Classifier. So we got our feature columns equals our feet columns. So we set our feature columns to feature columns. And again, that's a list of our columns that are TensorFlow specific columns that we created. And then the number of classes, there's 2, I guess. Enter. So then once you do that, this little config file of TensorFlow will spit out saying like, okay, I'm doing this thing. I guess it stores in var folders, 3v, whatever. Random seed. Check every so hour. And then the last part is we do the training. So this part's fun because you actually get to see it doing stuff. Probably my favorite part. So we say our input function is the input function that we created. And then we provide the steps, so we say 1,000. And that's a good start. So you can actually change this number. And again, I've noticed the more you increase it, the better the accuracy. But again, it does teeter off. Now, we are using a small data set. This will work on your computer, but in the event where you're doing something ridiculous like image processing, it just becomes way more. The way they do image processing is it looks at every single pixel and looks to see either the RGB numeric response to that specific pixel, and then compares it across a bunch of different layers. And it's a lot more computing. This is pretty simple and clean. So should break that. Is that it? No. Oops. There you go. So now it's running, and now it's learning. Or it should be. There you go. So there it goes. Sweet. So then I'm going to change this to 2500 so maybe it'll be a little bit more accurate. So what it does here is it just threw out that old model. Now it's relearning a new model. Same data. It's just taking more steps to get the answer. Cool. Then the last part is we just pop in where we have our my presentation. Yeah, the next point. Next part is we just pop in that test data and then evaluate it. And we're done. Put that in, do that, we're done. Cool, so it looks like it just finished. Now we do the evaluation function. So basically the exact same thing like we had for our other one. It's just data that is not going to change the actual model. Y labels. So we set our X to X test, Y to Y test, batch size 10, number of epochs 1, and then shuffle equals false. I really don't remember. be honest. Do 100. Try 1,000. Let's try 1,000. Might have been a typo. This one, no. So, is it reviewing the answers? It is adding in the new data. So it has never seen these ones before. So it's taking in this new data and saying like, okay, I believe it's this, and then seeing if it's correct or not. So it's not technically reviewing it. It's just having new data that it was not aware of before.
So maybe the epoch having been obscured, so maybe the epoch is one because you're not generating anything, you're just putting in values that were already there.
That could be. That could be. I'll test it with both. Why not? It's fun, right? All right, and then, so do we run this? So now results equal model.evaluate, and then we just put that evaluation function in. We are done. Cool. That's doing that thing. Sweet. So now if we type in results, boom. So we have, this is our accuracy, 0.7532. So we have about a 75% accuracy of determining this. Now I am actually curious to see what happens if we increase the epoch. I imagine this will take 1,000 times longer. I don't think the model should change though, or the results though, but we can, let's see. Okay, and then results. Oh wait. Yeah, so the accuracy didn't change, so I'm not too sure if the epoch changing at the last. Yeah. Yes. Correct. It's not doing any learning. That's correct. Yeah. I don't know if I used the word comparing, but yeah, it's basically just running it through the model and determining what's correct. That's right. Yeah. All right. Does anyone have any questions? I know this went pretty fast. I try to do my best to make this as palatable and appetizing as possible within the allotted time, but it was a very interesting challenge. So I hope you guys got something out of it. I will be around almost until I die. So like you guys can message me. I've really gotten into data science just recently because the amount of things you can find and discover through it is just so fascinating to me. As much as I love security and how people move around and get around things, this is definitely the way. And especially for like malware analysis, like as we classify different malware, we can determine other types of relationships, and eventually malware is going to be cool enough to use ML on its own. So, or some of it already is, but yeah. Does anyone have any questions? If not, yes, please. That was better. Yeah, exactly. It's so minimal, but it really depends on what you're doing this for. Obviously, if you're doing some fintech stuff, like that the difference between a 0.001 could be $1 million or a few $1 million, right? So really depends on what you're doing the data for. But yeah. All right, everybody. Well, I hope you guys got something out of it. Again, I try to do the best I can, so I hope you guys really enjoyed it. You guys can get my information on the website as well. So thank you. What up, man? Yeah, let's take a look. Let's take a look.
I want to run through this tomorrow pretty bad.
Yeah, dude.
I just don't know. It's on my computer.
Yeah, it is. Okay. Are you using Juniper? The Jupyter notebooks or anything? Okay, cool. Let's try that then.
I'm just trying to run. I'm trying to get the environment set up first.
Okay.
The Conda NV.
Okay. Did you run that script?
The mini Conda one.
Yes.
Yeah, but I already had Anaconda downloaded.
So I did too, but the problem was that for whatever reason, it still wouldn't let. It had the exact same issue,
should I try
and then
and
I
run
tried
that again?
Yeah, go ahead and try
It's on my
that,
desktop, I think.
and that should give you.
can tell you Mark. That's a good point. That's a good point. And I've been thinking already, like, well, I could use something like software, or I'd be interested in that keyword, actually. I think I would enjoy that. And then just keep learning and keep going. And just the way that it's Any company that comes up with entry level